Okay, so now we're going to look into the last model, that is the third one, and the last one, probabilistic models. Okay, so for example, okay, I'll start with an example where you have A and B, okay, and your A, okay, let A denote the variables that you know about, okay. Example, you could have your instances, the feature value of the instance, okay. This is going to denote the variables. A is going to denote the variables and B, okay, this will denote the target variables. Target variables, okay, that is, for example, your instance class, okay. Here, your example was instance feature class, instance feature class, and here for your target variables, your example is your instance class. Okay. And now what are we going to do? We are going to model the relationship between A and B. Okay. Okay. How are we going to do it? We are going to do it by representing and manipulating the level of uncertainty, okay, with respect to these variables, okay, through probability distribution. Okay. I'll repeat it. I'm going to repeat it again. We have two sets, okay, A and B, where A is your variable and B is your target variables. And what are we going to do? We are going to model the relationship between A and B. And how are we going to do it? We are going to do it by representing and manipulating, okay. Representing and manipulating the level of uncertainty, okay, with respect to these variables, okay. We're going to represent and manipulate the level of uncertainty, okay, the level of uncertainty that exists among these variables, okay, through what? Through probability distribution, which is called as probabilistic models, okay. Okay, so that is probabilistic model, trying to, you have your variables, the variables exist in the form of your data whatsoever, and then you are trying to represent or manipulate them for what? With the level of uncertainty that exists with these variables through probabilistic distribution. Okay, that is how your probabilistic models work. Your example, one of your example is Bayes rule. Okay, and we look into an example of that too. So now this is the given following data set, okay, which contains 4 symptoms and 1 class, that is flu. Okay, and now what are we going to do? We are going to apply name-based classifier to determine the diagnosis class for the symptoms. So what probably if we take up the first one, chills, yes. Running nose, you have no, and then headache mild and fever, yes, and then flu no, right? It differs for each set of the data. Okay. And now, so what is the task here? The task of the algorithm is to look at the evidence, okay, and to determine the likelihood of a specific class and assign a label accordingly to each entity. Okay, so I'll just phrase it for you again. A data set has been given to you. If you're going to look into the data, it is very clear, right? It is clear. There is no other explanation required. So what are we going to do? We are supposed to determine the diagnosis class for the symptoms. So what is the task of the algorithm here? The first one is to look at the evidence. Is to look at the evidence, and the second one is to determine the likelihood of a specific class. And the third one, to assign a label. To assign a label according to each entity. Okay. So this is what you try to do. Okay. When a set of data is given to you, this is what you try to analyze from it. Okay. So what does an algorithm do? This is what an algorithm would do. So coming to the next one, so as we talked about, we were talking about applying naive-Bayes algorithm, right? So what is this naive-Bayes algorithm? It is an example of a probabilistic classifier. Okay, so it is based on the idea of conditional probability. So what is this conditional probability? So we are starting with naive-Bayes, and then we have come to conditional probability. So what is this conditional probability? This conditional probability is based on finding the probability that something will happen. Okay, given that something else has already happened. Okay, that is your conditional probability. Yes. So what is this given here? This diagram that's given here. This represents conditional probability for you, right? Probability of A, that is point will be, what is this here? It is given inside A. So if we know that B happens, okay, so I'll again I'll repeat what I told about conditional. What is conditional probability? Conditional probability is based on finding the probability that something will happen, okay, given that something else has already happened. That is what the conditional probability means. So given here, this probability of A, where it is pointed inside A, if we know that B happens, okay, so here the point could be inside B. If B happens, then what is your B? What is your result here? I think you would have definitely learned this formulae and the equations in your higher secondary, right? Okay, this is your required result. Okay, so this is how we are trying to implement. Okay, probably I told in your very first when you were talking about the basics and the introduction, mathematics is your basics for your machine learning or for your coding and for your algorithm. Okay, that is your base for your algorithm, right? So this is how you are to connect. So you have learned all this in your higher secondary. And now if I'm telling you are going to implement probability into your machine learning, when you have a situation with a data set where you know that something will happen, given that something else has already happened, and you are going to try to predict your probability for that. This is your implementation, or this is your basic algorithm for that. Okay, and your next one is conditional. Okay, we've been talking about conditional probability, right? So if I could proceed with a previous example, okay, the example could be like this. Okay, yeah, this denotes your conditional probability. So I can take up where A could be the, your chills and running nose. So this is considered as posterior probability. Okay. So what is this posterior probability? That is, after observing the value of chills or runny nose, we are trying to predict the value of B. Okay, so that is what happens in your posterior probability. Okay, so there is something called decision rule. Okay, so they also call it as Bayes decision rule. So what is this Bayes decision rule? Again, we have a equation here. Okay. Okay, so what is this P of B that we're talking about? This is prior probability. Okay, we call this as prior probability, that is without observing data values. Okay, and your P of A, this is completely independent of B. Okay, and your P of AB, what does this indicate? This indicates the likelihood function. Yes, probably you learned Bayes decision rules, okay, and all that, but you should also try to understand what each term means, and only then you will be able to implement it or work based on it into a algorithm, right? So coming to the other part, your Bayes rule, okay? So your Bayes rule has something like this. So we are looking into prior, right? Prior probability independent of B and likelihood function. So you can also work on it like this. Okay, so now here is your prior. This one is your likelihood, right? And you have your posterior here. And this is your evidence that you're looking for. All right. So your evidence, what is this evidence? Your P of X probability that your observation X, okay, your observation X is seen regardless if whether it could be positive or negative, okay. And looking here in the same way, just like you looked into your Bayes rule, your posterior and all that, you have something called maximum posteriori, that is MAP decision rule, and maximum likelihood ML decision rule. Okay, and these are the equations. I don't think you would have like probably learned about it in your high school, but you can look into it. You can have a look into it, knowing that this is how you are trying to predict or go for, that is how your probabilistic models are used in. And you have two types of probabilistic models here. Okay. And the first one is predictive probability. Yeah. And your second one is generative models. Yeah. So this predictive probability, these models, what do? They use the idea of a conditional probability distribution. Okay, so you've learned what a conditional probability is, right? So this will use the idea of conditional probability distribution, okay, and using which, from which y can be predicted, okay. So this y can be predicted from this x. That is the reason why we are using the conditional probability. So what is predictive probability? So when I tell I'm using a predictive model, I'm going to either implement predictive probability or generative models, right? So what does this predictive probability do? It will take up the idea or the values, the variables, the outcome from the conditional probability, because its requirement is y. So since this conditional probability will have x, it will predict y using x. Okay. And generative models. So what do they do? These estimate the joint distribution. Okay. Okay, these estimate the joint distribution, that is P of y comma x, where once the joint distribution is known, then so what is the purpose of it? Like I said, once the joint distribution is known, then one can derive any conditional or marginal distribution involving the same variables. Okay, that is your joint. Okay, there is a joint distribution here. Okay, and we are going to derive any, okay, what are we going to derive? We are going to derive any conditional or marginal distribution. Okay, marginal distribution involving the same variables, which involves the same variables. Okay, so these are the two types of probabilistic models, and this is where they are used in. Okay, so let me phrase it with a conclusion for you. So we've seen three models, right? Geometric models, logical models, and probabilistic models. Okay. So this geometric model, where is it used in? It uses the idea of distance to classify entities. Okay. So this takes up the idea of distance and gives you classified entities. And your logical model, what do? They use logical expressions. Okay. They use logical expressions to partition the instance space. And your last one is probabilistic models. So what did we do here? We used the idea of probability. Okay. We use the idea of probability to classify, where again classifying here, but here we classify new entities. Okay, there is a difference here. Okay, so these are the three models that you've gone through, and I hope you're clear about it. Okay, so you don't have to worry. After probably I come back to the campus, I will be taking another like sessions for you on all these three topics. Okay, so probably at the end of all these sessions, I want you to, each assignment is attached. Okay, so see that you complete all the assignment and submit it on time.